All right, so we're continuing to talk about polynomial functions. And so the first thing I want to talk about is the degree and the number of solutions. We've talked about this a couple times, but I just want to make sure that we stress it again. Is that the degree you have, that's the number of solutions you're going to have. That's the number of possible solutions. So my degree for this problem is 4, so I should have 4 solutions. On this problem, my biggest degree is 5, so I should have 5 possible solutions. Now remember, sometimes you have the same solution twice, and that's when we will call multiplicity 2, but you still would count that as a solution. Okay, when a graph intersects the x-axis, remember that's called a 0, it is a real solution. Like you can see it, it's a real solution. Okay? If you don't have enough real zeros, then there are some imaginary ones that you can't see. And when you have imaginary, they have to come as sets of 2. Because remember, like the square root of -4, that was plus or minus 2i. So there always has to be a positive and a negative. An example would be is if I'm supposed to have 3 answers, but I only have 1 real, but I'm supposed to have 3 because it's x to the 3rd, so then that means I have 2 imaginary. So what's going to happen is we will always try and find the real answer first, and sometimes we're going to use graphing calculators to find it, and then after that, we will go ahead and see what other answers we can find. So let's go ahead and do this one. Well, this has a 4, so there's supposed to be 4 solutions total. Well, if you notice, I see 2 places where it crosses, so there's 2 reals. So that means there has to be some that are imaginary, so they have to be in partners and pairs of 2. And 2 plus 2 is 4, so I found my possible solutions. Now, the way you actually find this solution is at 3, this solution is at -1. And what I do is I use synthetic division to divide. So I'm going to put 3 in my box, and I'm going to write the coefficients. So 1, -2, 2, -10, and -15. 1 plus 0 is 1. Multiplied by what's in the box is 3. -2 plus 3 is 1. Multiplied by what's in the box is 3. 2 plus 3 is 5. Multiplied by what's in the box is 15. -10 plus 5 is 15 is 5. Multiplied by what's in the box, which is positive 15, and I get a remainder 0, which I should because it's a 0. Now, I just did this one. Now I need to do the second one. So now I'm going to put my -1 here, and now I'm going to do the same process. 1 plus nothing is 1. Multiplied by what's in the box, and I get -1. 1 minus 1 is 0. Multiplied by what's in the box, and I get 0. 5 plus 0 is 5. Multiplied by what's in the box, and I get -5. 5 and a -5 is 0. So now I've done my 2 real zeros that I found, and this is what's left. Well, this would have been an x to the 3rd, so this is an x squared, x, and no x. So I'm left with this, x squared plus 5 equals 0. Well, to solve this, I'm going to minus 5 on both sides, and so I get x squared is -5. And to get rid of a square, I take a square root. And so I get x is equal to plus or minus I, because remember the square root of a negative is I, 5. And then let's also write the other ones that we found. And those are the 4 solutions for that polynomial function. All right, so let's go ahead and let's fill this in, and then we'll do the problems. I probably jumped ahead of ourselves, but that's okay. So you plug the zeros into So you plug the zeros into the equation, and I like to use synthetic division. Synthetic. Remember that they're the opposite. If you have imaginary, then you need to have a negative and a positive. Once you find your factors, you multiply and add like terms. Okay, so why don't we go ahead Okay, what I'd like you to do now is find the zeros. Okay, so one thing you could do is you could always just graph it to see what happens first. So let's clear this out. And let's plug in this first one. Oh, there's a glare. Maybe it'll adjust. Is it going to adjust? It should adjust. There it goes. So let's clear this out. X to the fourth minus x squared plus x. Let's see if we can find our zeros. Well, I can't really see all of them, but I know that that one's probably at 1. A good way to check is you see this where it says table, you hit second graph and go find out when you have a 0. And I have a 0 here. Have any other zeros? Oops, I got to go over here. And I don't. So really what I'm going to do is I'm going to take out this x, and I'm left with x cubed minus x plus 1. And so now, there's no more zeros. So now what I need to do is I need to find out where the other ones are. And they're going to be very frustrated with this. Okay, so let's go ahead and find all our zeros. The best way to start is to see if we can find any on the calculator. I'm going to plug that in. I'm going to hit graph. And I can see one. It's at 0. And I could double check by going to the table. Yeah, you see how 0 is paired with 0? Whenever the y is 0, that's going to be a 0. And so I know that I have a 0. And so now if I take this out, I'm left with x squared minus x plus 1. Now here's an issue. I don't know what times what is 1 adds to give a negative 1. This, I'm going to have to use quadratic formula. Remember the opposite of b, plus or minus square root, b squared minus 4ac all over 2a. Sometimes we're going to have to do that. And so my a is 1, my b is negative 1, and my c is 1. So it's going to be the opposite of b, so 1 plus or minus square root b squared minus 4ac all over 2a. And so I plug in my discriminant. Remember, that's the thing underneath. So -1 squared. So that's a -2. -1 squared minus 4 times 1 times 1, which is just 4. So I get a -3. So it's 1 plus or minus the square root of -3 over 2. And the only thing I have to do is I have to go ahead and get rid of this negative. So it's 1 plus or minus I square root of 3 over 2. There's the first answer. And here's the other answer. And so there's the two answers for that problem. All right, for number 2, again, start off by plugging it in the calculator. Let's see if we can find anything. Maybe we'll get lucky and find some x's and don't have to do much work. So I'm going to go find where it crosses the x-axis. And those are my zeros. Okay, so I think I found more. It looks like I might have a 0 and I might have a 2. So I'm going to go to that table function by hitting second table, and I'm looking for a 0. Oh, and look, I found several of them. I found -1 is one. I found 0 is one of them because there's another 0. And then I also found this one down here. Well, if you think about it, I'm supposed to have 4 answers, but I only have 3. So one of these has to have a multiplicity. So let's look back at our graph. And look right here. You see how it folds at the 0? So this has multiplicity of 2. All right, let's look at the last one. Again, you always want to start off to see if you're lucky and see if you can find any zeros. So I'm going to plug this in. 3x to the third. Oops, that's not even the right spot. 3x to the third plus 9x squared plus 4x plus 12. And I graph it. Oh, and I found one. Oh, that's all we found. We found, oops, got to go to the table. Let's see, we found it right there, -3. Okay, so I know x is -3. So I'm going to take this and I'm going to put this in synthetic division. So my coefficients are 3, 9, 4, and 12. 3 plus nothing is 3 times what's in the box, -9. 9 minus 9 is 0 times what's in the box, which is 0. 4 plus 0 is 4 times what's in the box, which is -12. And 12 minus 12 is 0. I started with x to the third, so my answer starts with x squared. And so it's x squared, x, and then nothing. So I have 3x squared plus 4, and it's supposed to equal 0 because I'm finding factors that equal 0. So I'm going to minus 4 on both sides. So I get 3x squared is -4. I'm going to divide by 3. Come up here. And so I get x squared is equal to -4 over 3. Well, to get rid of a squared, you take the square root. So I get plus or minus 2i, because the square root of -4 is 2i over the square root of 3. And remember, you're not allowed to have a square root, so we're going to do this last thing. I'm going to do that rationalizing thing where you need another one. And so now it's plus or minus 2i square root of 3 all over 3. It's that answer and the original answer we found, which was -3. So when you're able to find the zeros, it makes it nice because there's not as much work. But sometimes that's not going to happen, and sometimes you are going to have to find other answers by using synthetic and then either solving like this or solving the quadratic formula. Now, one thing I do want to point out is that you know the difference. The reason I had to use quadratic formula up here was because I had an x. Down here, I didn't have to because all I had was an x squared. So when you have an x squared and an x, you're going to have to do the quadratic formula. All right, let's go back to our last problems. To write equations, given the zeros, the first thing you do is you plug the zeros into the parentheses. And remember, it's the opposite. If you have imaginary, then you need to have a positive and a negative imaginary. Once you find your factors, you multiply and combine your like terms. So what we're doing is we're going backwards. All right, so let's zoom in on this first example. There. Okay, so this first example, whoa, that's super close. I'll focus close. I have those 3 zeros. So as a factor, I know that this one's x minus 2, x plus 3, and x minus 1. Well, what you have to do first is you have to FOIL or distribute 2. So I'm going to do these. And this would give me x squared plus 1x minus 6. If you FOIL that, I just kind of combined terms as I went. Now remember our box. I have to multiply this by x minus 1. So I'm going to kind of draw my box down. And I have an x and a minus 1. And I'm going to fill in my Punnett square. So I have x to the third, x squared, negative 6x, negative x squared, negative x, and positive 6. So I have x to the third, positive x squared and negative x squared cancels off, negative 7x plus 6. And that's the function that gives us those 3 zeros. All right, let's look at the next one. I'd like you to try 4 and 5 on your own. So start off by writing the factors. And then once you have the factors, you could distribute. So you should have had x minus 5, x plus 2, and x minus 3. If I put these together, I get x squared minus 3x plus 2. Got to bring this one down. And now I'm going to do my box again. An x and a negative 3. My box is kind of out of shape. Let's see if I can fix that. Okay, x squared times x is x to the third. Negative 3x times x is negative 3x squared. 2 times x is 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 3 is positive 9x. And negative 3 times 2 is negative 6. So now I have to combine my terms. I have an x to the third, a negative 3x squared, and a negative 3x squared is a negative 6x squared. 9x and 2x is 11x, and negative 6. And there it is. Last one. This one's nice because this is just an x, and a multiplicity of 1 is just an x plus 1 and then an x plus 1. I know that these together make x squared plus 2x plus 1. Well, now I just have to multiply by x. So this one was actually much easier. And so I get x to the third plus 2x squared plus x. So that's the function that gives me my solutions of 0 and negative 1. All right, let's look at the last one, number 6. Now, remember what I said is when you have an imaginary, they come as partners. All right, so if I have a positive 5i, that also means that I have to have a negative 5i. Now, when you get an I, let's kind of just look and see what that means. The only way you could get a plus or minus 5i is if you take the square root of something. Well, the only way you get an I is if I take the square root of a negative. And the square root that gives me 5 is 25. So now that's telling me, I'm going to kind of work backwards, that I have an x squared as a negative 25. And then if I work backwards again to get rid of that minus 25, that tells me that my factor is x squared plus 25. And so that's kind of the process you have to use to kind of think about what it is when you have the 5i. And so now, x minus 3, x minus 5, I put these together, and that's x squared minus 8x plus 15. And now I'm going to bring this one down, and I'm going to make my box. So x squared times x squared is x to the 4th, negative 8x to the 3rd, and 15x squared, 25x squared. 8 times 25 is 200, x, and then 25 times 15, that's a big number. That's 375. Now usually our diagonals add up, but they're not going to add up this time, so we have to be careful. My biggest is x to the 4th. Then I have an x to the 3rd. My x squares that can go together are here and here. And so 25x squared plus 15x squared is 40x squared. Then I have a 200x, and then I have a 375. And so that's the polynomial function for that. So now what you do is just you have to remember that when you have a degree, it should be the same number of solutions. If you have imaginary solutions, they come as partners. Whenever you're trying to find all solutions, start off by graphing it and see if you can find any zeros. And if you're able to find real zeros, then you use synthetic division. From synthetic division, you're either going to solve or you're going to use quadratic formula to find the remaining zeros.